We are going to calculate an approximate value of pi. To do that, we need to draw a circle and a square inscribed on it. We need something to cover them up, in this case a bunch of cent coins. Let us start with our circle, which has an arbitrary radius r. We use the Pythagorean theorem to calculate the side of the inscribed square. R squared plus r squared equals to r squared, so the side of the square equals square root of 2 times r. Therefore, the area of the square is equal to 2 times r squared, while, as it is known, the area of the circle is pi times r squared. If we calculate the quotient of both areas, the square of the radius is cancelled out, and we obtain that this quotient is equal to pi over 2. We have found a way to calculate pi by measuring the areas of both the circle and the square, calculating the quotient and timing it by 2. Measuring areas without doing any calculations or any measurements is the tricky part here. We're going to approximate the area by just filling it with little pieces. In our case, 1 cent coins. The area of the circle is approximately 105 coins. The square can be covered using 67 coins. So we put those numbers into our fraction and obtain an approximation of pi. Pi is more or less 3.134. So how good an approximation is that? We can compare it to the actual value of pi and measure the relative error, which turns out to be 0.231%, so less than 0.25%. In other words, the error is less than 1/400th of the value of pi. Not that bad indeed.